A tank initially contains a salt solution of 3 grams of salt dissolved in 100 liters of water. A salt solution containing 0.02 grams of salt per liter of water is sprayed into the tank at a rate of 4 liters per minute. The sprayed solution is continually mixed with the salt solution in the tank, and the mixture flows out of the tank at a rate of 4 liters per minute. If the mixing is instantaneous, how many grams of salt are in the tank after 100 minutes have elapsed? Okay, so my thinking here is just to write out, is it going to be essentially a system of differential equations, or not a system, but a differential equation which represents the inflow and outflow of salt? And I mean, the final question is asking how many grams of salt are in the tank. So I think what I'll do is I'll have a variable which represents the number of grams of salt in the tank at any point in time. And I will just have to keep track of the rate at which salt comes in and the rate at which salt comes out. So we start with 3 grams of salt in total. And the spray of water that's coming in has 0.02 grams of salt per liter. And it also has the rate at which, it also tells us the rate at which salt is being put in. So we can immediately calculate how fast salt is being added to the tank. Then, so we will need to compute, if the mixture flows out at 4 liters per minute, we basically we'll need another variable which represents the concentration of salt in the water, but that is of course going to be related to the total amount of salt. So I mean, the concentration of salt in the water in total, that's going to be essentially how fast salt is leaving the tank. So we'll want to figure out the concentration of salt at any point in time, but that is of course going to be directly related to the total amount of salt. Okay, so why am I zoomed in here? So G of t will be the mass of salt in the tank. And so this, of course, says that G of 0 is equal to 3. And this will be in grams. And I think everything is measured in the same units. You know, water is always liters, time is always minutes. So T will be time in minutes. So G of 0 is 3. I'll let C of t be the concentration of salt. And this is of course measured in grams per liter. Okay, and C of t is equal to G of t divided by. So in terms of volume of water, 4 liters per minute volume of water coming in, and 4 liters per minute going out. So the volume never changes. If this problem had, if the rate of water coming in and out were different, we would also want to track the total volume of water in the tank. But this should be just fine. Okay, so G prime of t. Let's compute the rate at which salt comes in. So we have 0.02 grams per liter times 4 liters per minute. So this is a, concentration per liter times number of liters per minute. we get exactly a cancellation of liters and liters. In fact, let me make the simplification immediately. 0.08 grams per minute. Oh, hold on. I'm going to change G to F so that we don't confuse the symbol for the function with the unit gram. Okay, units make sense here, right? You know, F represents a mass, so F prime should represent a rate of mass change. There we go, grams per minute. And we also have salt flowing out. So C of T is the concentration at any point in time. And we have to multiply that by the rate at which the water is leaving, which is again 4 liters per minute. Yep, so C of T, I guess technically here I should actually have 100 liters if I want and this F of 0 should be 3 grams if I want to keep track of units properly. So 0.08 grams per minute minus C of T is F of T over 100. So I have F of T yeah, this works. Okay, I have F of T times 4 over 100 minutes. Okay, so I've canceled the liter and the liter. F has units of grams, so I have, you know, the 1 over minute, and there's a gram there. There is a gram in there, so the units all make sense. So F prime of T is equal to 0.08 grams per minute minus F of T times, what's 4 over 100? Is that 0.04? I'll just write per minute. I'm going to drop units now while we go through and like solve this. How do I want to write down the solution? Let's change this first. I'm gonna write this as F prime is equal to A minus B F. So A is equal to 0.08, B is equal to 0.04. If I write this as F prime plus BF is equal to A, I don't really want to use an integrating factor here. I should be able to just write down the solution of this thing, right? F of T is equal to A E negative B T is it plus F, hold on. Forget it, let's do integrating factor. So this on the left is e to the bt f prime plus b e to the bt f e to the bt a. Okay, integrate from 0 to t. A integral from 0 to t of e to bu du. So I have e to the bt ft minus e minus f of 0 is equal to a e to the b t minus 1 divided by b. Okay, so f of t e to the bt is equal to f of 0 plus a over b e to the bt minus 1. And so f of t is equal to e to the negative bt f of 0 plus a over b 1 minus e to the negative bt. And now we'll substitute some quantities. F of 100 is equal to e to the negative. So b is equal to 0.04. You can multiply that by 100, so negative 4. F of 0 was 3 plus a divided by b is 2 times 1 minus e to the negative 4. So simplify. 3 e to the negative 4 plus 2 minus 2 e to the negative 4. I end up with 2 plus e to the negative 4. I hope that's one of the answers. 2 plus e to the negative 4. Yeah, that's answer E. And I guess like it makes sense. Let's ask her. Let's check some do some sanity checks. The total rate the total rate of salt coming in and out, it's going out faster than it's coming in, at least initially. This at time 0, this is equal to 3. So salt is leaving at that rate initially, and it's coming in at that rate, so it's decreasing. And that'll be true until f gets down to 2. So the limiting value, like if you did this forever, the total, then the inflow of salt would equal the outflow, and that happens when the concentration, or the total mass is 2. I mean, the rate of 4 makes sense. Like your clearly the exponential factor should be 4 or 0.04, however you want to think about it, because that's the term which dictates stuff coming out, or it's the term that's proportional to f. And there are some options that have 2 minus something. Those are clearly incorrect because the salt content starts above 2, starts at 3, and it's decreasing. But if it ever hits 2, it'll stay there forever. So, yeah, I mean, I'm very confident in this answer given these sanity checks at the end, and I mean, I'm confident with how I set the question up anyway. So, yeah, nice little one. Sort of engineering problem, transferring a problem stated in words into a mathematical system, and the answer just pops out. If I find an error, I'll make sure to highlight it somewhere. Thanks for watching.